You're listening to the Future Tech Podcast with Richard Jacobs. Future technologies such as artificial intelligence, stem cells, 3D printing, gene editing, Bitcoin, blockchain, the microbiome, quantum computing, virtual reality, and exploring space are much closer than you might think. In fact, many early versions of these technologies are in play right now, and the companies that are using these technologies are the focus of this podcast. My goal for you, the listener, is to learn from these podcasts. You may very well learn something that may change the course of your life for the better, steer you towards a new career, or give you insight into addressing a thorny medical problem. Remember, this podcast and its content is informational in nature only. No medical, tax, legal, financial, or psychological advice is being given. If you've enjoyed the podcast, please listen, subscribe, like, and tell your friends about it. Thank you. Hello, this is Richard Jacobs with the Future Tech Podcast. I have Nathan Wilmot. He's an Associate R&D Director, and Keith Wilson, a Strategic Marketing Manager at Dow Industrial Solutions. And we're going to be talking about their recent launch of a new 3D printing product, which they'll describe. So guys, thanks for coming, and how you doing?
Great. Thanks for having us both today.
Yeah, if you would, let me know about Dow Industrial. What's the premise of the company, and how does the new 3D printing product fit into the portfolio?
So maybe a little bit more broadly, we're part of Dow. We're Industrial Solutions, a business within Dow, focused on bringing primarily solutions to the industrial sector, whether that's manufacturing or otherwise, more or less.
And then within manufacturing, which is very broad too, what area are Dow Industrial Solutions focused on, or maybe in particular, what are you focused on within manufacturing? Because that's also very broad.
Sure. So that could be everything from maybe additives or ingredients or products used to impact the way that water interacts with certain materials, or in a really pretty wide variety of areas. So everything from, I can say personally, breweries and wineries, fluids that get used there for cooling and thermal stability, to products that are used even in concentrated solar power and other renewable energy type applications. So incredibly broad, you could say.
Okay.
And then within additive manufacturing specifically, we've done quite a bit of work looking at how we can bring the power of Dow, the material science expertise, and many of the innovations maybe that have been brought from a variety of businesses or applications in the past to the world of additive. So we've been looking heavily at the partnerships that we have and how we can best leverage our strengths and the strengths of others to come up with solutions that'll hopefully further the adoption of 3D printing and a variety of new applications.
Yeah, that's what I was going to ask you. Is the public doesn't know the term additive manufacturing probably as much as they know 3D printing. So that's what I wanted to ask you about. So in 3D printing, I've spoken to people that are trying to fabricate out of metal, some out of different plastics, et cetera. But I would guess composites are probably the next goal for all 3D printing, or maybe it's already here. So, maybe tell me about the state of 3D printing as it is now, and what are some inroads you guys have made in it?
So our strength really lies on the polymer space, and that's where we've been focused already. You mentioned before the universal support material that's based on one of our polymers, and brings in an added layer of kind of ease of use and sustainability to FDM or the filament type of 3D printing, where now if you're building complex shapes, you oftentimes use a support material, and our support material has been found to be considerably more easy for the user, if in an academic or potentially a home or an office environment, to deal with in terms of breaking that down than others. More recently, we launched our first build material. This is our OBC, and here we're really trying to move the needle on utility for 3D printed parts, where historically they're primarily prototypes, but how do we start making them more functional? And we found that with the OBC, we can bring a layer of toughness to it and chemical resistance, making it more durable. So now we can start to consider some applications and not just work in the prototype space.
Yeah, I've heard that a common misconception is that you 3D print something and it's ready to be used, but there's a lot of finishing and refinement to a lot of products and parts, right?
Yeah, there's that, and not every material that you're gonna have access to in your 3D printing store, right, it is going to be useful for the applications that you're trying to potentially use them for. So, I think that there's a lot of relatively simple things that you can 3D print in your house. Toys or little gadgets, or even I've seen some things with like drawer pulls or shower curtain hangers and stuff like that, where the environment and the use conditions aren't really that hard, right? You don't need it to stand up to long-term durability needs. But that for additive manufacturing and 3D printing to really kind of take over the industry, we need to start developing those materials that are 3D printable, but also match the long-term performance requirements that are needed in the variety of end-use applications that might exist.
Well, what are some of the drawbacks to the current materials? You talked about using a base material, but just as a consumer, the only thing I've seen is people with 3D print like Yoda's head or a Star Wars thing, like little trinkets. I haven't seen really the industrial or manufacturing applications of it.
So the Yoda head and the little trinkets and toys, right? Those probably are made out of either ABS or polylactic acid, which are two of the most commonly used 3D printing materials that you buy for your at-home printers, which, the filament type printer is what most people use. And that's what's been around for a long time. And they've been adopted with very good success, and people really know how to print them well. You see now coming some new technologies, some new materials like thermoplastic polyurethanes or polyamides, and they move the needle again on that kind of mechanical durability, more engineering type polymers, and that's where we see the OBC fitting as well, in that it brings a significant performance benefit over some of the PLAs and the ABSs in terms of long-term chemical resistance, mechanical toughness, while keeping it easy to print, right? So sometimes when new materials come out, they tend to be a little more challenging to print, and there's a little bit of a learning curve there. And we've really tried to make this as user-friendly as possible.
I guess maybe just a substance that'll flow, but then set quickly when you want it to set and act mechanically how you want it to act, right?
Yeah, that's exactly right. So, in the kind of benchmark 3D printers, you're taking a thermoplastic material, you're running it through a hot end to draw out your layer by layer 3D print, and having something that melts at a reasonable temperature that the printers can handle, while, like you said, setting and solidifying is relatively quickly, right, while keeping adhesion between the layers and not having warpage and dimensional instability, is really what you're trying to drive for here. And that, as new materials are commercialized, is something that has been a challenge.
Maybe just
go ahead. Go ahead.
Sorry to interrupt you. Just as maybe a step back at a higher level, I would just say that, or just to add on to what Nathan's saying, that and I've heard this quoted a million times at conferences, trade shows, market reports, et cetera, but if you think about the Industrial Revolution offering standardized products to the masses, a lot of times people say that 3D printing is offering customized products to the masses. So if you were looking 200 years ago at getting a pair of shoes, maybe you had to go to a specialized cobbler, skilled worker that would be able to make those shoes just right for your feet. And then that went away very quickly as shoes started coming down production lines in standard sizes and widths. But as we all know, right, there's a lot of people that don't have identical feet. And so having the opportunity to customize those products, whether it's a customer end user or also just being able to produce larger parts, and instead of needing a number of component producers, having the ability to print that part as one continuous object, is some of the areas that we see the most value as far as 3D printing goes. And so if you take that example and then you say, well, what kinds of materials do I see on a regular basis and some of the products I use day in, day out, like my shoes, that's the variety of materials that you're able to choose from in the world of 3D printing today is not necessarily mirroring that of what you would see in the manufacturing environment outside of 3D printing or additive. And so that's I think at a high level where we're trying to go, is to develop those materials with those properties that can enable those applications to exist.
So I would think composite materials are even a step more difficult than just uniform materials that have all the right properties, right? Or can they go hand in hand and both can be developed, no problem?
Oh, that is an added layer of complexity, yeah, right? So if you're going to consider composites as we would normally now, either glass fiber, carbon fiber, et cetera, they do exist in the 3D printing space, but yeah, there is an added layer of challenge there that you don't maybe have when you're just using base polymers. But they've been commercialized, and they're starting to find some good use too. Like I come back to, like we talked about before, I mean, it's about finding ways to make the same materials that exist now, be it in automotive or other applications, but allow this customization piece through additive manufacturing that traditional techniques don't always allow.
So what are some of the near-term goals that the industry has, or you guys have? What is it, a particular type of material? Is it a need to 3D print a product and have no finishing needed? I mean, what are some of the things you're looking to do?
I would say that, just generally speaking, what we see across the board is different areas of expertise, right? You've got printer manufacturers who may have an incredible amount of knowledge when it comes to how you can make a printer work, how you can make it more modular in terms of its design, so that it can make a variety of structures based on the end user's needs. Then you have material science companies like ourselves that are looking at how we can innovate on the material side, and all of this then feeds into a designer at the end of the day that's taking that technology, using some sort of software, and designing a part with the material properties that they need to hit to have a finished solution. And one of the things that personally I'm really excited about with the way that the market has been moving more recently is that as 3D printing has become more and more open as far as collaboration, we're seeing the speed of innovation, the speed of new things coming out happening at a much more rapid pace. So just in general, the speed that you're able to take, that may take to find that final solution for any given application, is arguably getting much faster because of these types of collaborations. That's very much so kind of the area that we're focused in also, is looking at how we can leverage our strength as a material science company that's developed a variety of polymers and a variety of applications to improve them or to enable those applications to exist. How can we take that knowledge, that expertise, and then partner with companies that also have their own expertise in 3D printing, whether that's the printer manufacturer, the software developer, the designer themselves? How can we partner and collaboratively innovate to bring new solutions faster to the market?
Do you have any specific examples of materials or products or methodologies that are relatively new you've created, and what the effect was by using them?
So Nathan kind of touched on this a bit earlier, but as we were having many of the conversations that we've had over the last couple of years with some of our partners, one of the things that we had heard was that we needed the need for a material that was truly water soluble and that could be used with a variety of build materials as a sacrificial support. And that was where our focus on our initial product that was developed and launched, the universal support material, that's where that began. And it's safe to dispose of. It reduces some of those safety and environmental concerns, which is also a big part of Dow just in general. But then with the new material we've developed, over and over again, we were hearing that in applications where you may need chemical resistance for either blending, mixing, or where you might have a part that could get exposed to a chemical in its use. That type of material that had that chemical resistance that could also have the durability factor did not exist. So if you think about how many polyethylene totes might be out there that are used for transporting chemicals or other products, there's a reason that it's polyethylene, right? And that those same properties didn't exist in the world of 3D printing previously, and that's where again, our newly developed product, the OBC, olefin block copolymer that we launched a few months ago now, that's where that started, was having those conversations and understanding that there was a set of applications that didn't have a solution standing. And so again, as we think about the ability to make materials that are maybe more elastomeric and that are capable of being quickly printed for use in footwear or in component part production for larger manufacturers. I mean, that's an area that we certainly see an opportunity to improve, especially, and I think Nathan said this earlier, when you start thinking about that term engineering grade materials, it means that it's got a certain level of durability and toughness to it. And that's again an area I think that, broadly speaking, the industry as a whole is looking for, because if you think about the number of products today that are injection molded or that are produced using other manufacturing methods, there's certainly an opportunity there to be able to streamline production of those parts through 3D printing.
Well, I mean, things are made of what they're made of. So do you have to simply modify the existing materials that, engineered manufactured products are made of, or do you have to come up with totally new materials? And then there's, all the properties of the new materials. So it seems like it would make this task very difficult to come up with a whole new set of materials, that already have been proven or used in manufacturing.
Yeah. It's quite difficult, actually, right? And in some cases, people have found that you can use the same or some simple modification of an existing material that's used and put it into a 3D printer or other AM type machine. But in a lot of cases, you can't, right? Because the limitations of the processes that have been developed in injection molding or other manufacturing techniques, casting, things like this over the last several decades are really, the materials are built for those. And now we have, this new manufacturing technique and there's some adjustments that have to be made. So, we have a pretty large R&D group now that's working on trying to do just that and adapt the existing materials, or at least get towards those end use properties in a 3D printing or an additive manufacturing technology.
Any products that are kind of the great hope for 3D printing that aren't there yet, but maybe are close? Either material properties or objects to be printed themselves. Maybe circuits to be 3D printed. What are, again, the great hopes that will be a huge boon when they happen?
Not to toot our horn too much, right? But I think the commercialization of the OBC and having a printable polyolefin that we launched in just November of last year is in that step of something that is nearly a great hope, because polyolefins are the world's most widely used plastics. They're excellent for their durability, for their toughness, for their chemical resistance, for their recyclability. So they have a good life cycle with them as well. But they were few and far between in the 3D printing space. And we were able to develop something that maintains a lot of those heritage properties, but again, is really quite easy to use for even a novice user in 3D with 3D printing. So that is, that's our first foray certainly into developing these new materials that will ultimately help transform additive manufacturing as a more usable tool.
And maybe just to get to your question a little bit more from my angle, when you think about the sort of the holy grail of 3D printing, I think that changes quite a bit as you look at different end users, right, and different applications. I think at a high level, even though that goal may vary, or that holy grail may vary by application or end user, at the end of the day, what many companies are striving for in this space is to develop total solutions that can be used without the limitations necessarily being there and saying, well, we would love to be able to 3D print this, but these properties aren't there to enable this application, or we would love to be able to 3D print this, but it's too slow. And as I think about too, maybe more broadly, the impact on society, the ability to have a scalable printing technology. So I'm sure you've seen examples of people 3D printing large structures, buildings, or cars, the bodies of cars, or a variety of other applications. But I mean, if you think about 3D printing as being a broadly used term that describes a lot of different technologies, I kind of think of them all as being different tools in a toolbox for different applications. And so again, it's going to vary as far as what that holy grail is by application. But at the end of the day, what I think companies and the market is looking to do in general is to be able to offer new solutions that either improve mechanical performance or offer the ability to produce parts in a just-in-time manner in remote locations where that's maybe more important, or to be able to be deployed really rapidly, right? So if we take the example of being able to 3D print really large structures for disaster relief, for instance, having a material that can withstand the environment that printer is being deployed in and where that structure is being built, that's really important. And so we're looking every day at different applications that are needing solutions, and whether that solution comes from just a tweak or change of material properties, or if it's a mix of those material properties with the right type of printer and the right type of software, other technologies that complement the printing itself to enable that application to succeed. I think that's, again, it's going to vary widely, but it's incredibly exciting to be a part of it, right? That we're seeing these things happen not on a yearly basis or a once in a decade type basis, but on a daily basis.
So what's ahead for the next 6 months or a year? What is coming now? Just more widespread adoption of the polyolefin, or are there other initiatives that you can talk about?
I would say that one is for sure something that we're excited about, and then expanding upon that, right? So looking at how we can continue iterating on that initial formulation of that polyethylene based material that we've developed and launched, and whether that comes with functionalization or with by other means, we're fully focused on how we can deliver solutions that the market's looking for. So we're not just blindly doing that, but we're really looking for communication with that market directly, and hearing from the end users, from those designers that are struggling to make that part, what's holding them back. And we're learning a lot of this through, again, the partnerships that we have, whether that be a printer manufacturer, a software developer, et cetera. But I think we all play a critical role in sort of delivering that. So the hope is definitely that we are able to continue expanding on what we're doing right now to help further the industry, further the adoption, especially in the manufacturing space. But then also just looking at how much can we push the limits of some of the polymers that we're developing as far as in-use applications, and whether that's leveraging this initial polyolefin or going down the path of different options that we may have in the polyurethanes or silicone space. These are all areas that we are very actively exploring.
And then, last question: what's the holy grail of the industry? What's like super ambitious and may take 5 to 10 years or more in order to accomplish? But what is that thing?
I think generally speaking, across the industry or in the market, I guess it's to be able to have anything you want on demand, right? And what does that mean? I mean, if like he said, I want a certain pair of shoes that are some color and have some proper fit on my foot, and the soles are geared towards my running style or something like that. To be able to manufacture that easily, quickly, and cost effectively, those are the type of things that are really the holy grail for additive manufacturing, and how it can replace more traditional techniques while being infinitely customizable for every person on this planet. And that's a long way off. That's certainly more than 5 to 10 years off, but that is truly, I think, the vision of the industry as a whole.
Okay, I didn't know if there was being able to print again circuits within inside of the body of a product was a big goal for the industry, or any other specifics.
I think that certainly. I mean, I would love to hear more on where that comment's coming from, because it's something that I think about all the time. The concept of not just taking your car to the mechanic and finding out that something's wrong, but your car alerting you well before that part is broken that it's at risk of breaking, right? By having some of those embedded electronics, I think is something that certainly would be really exciting, not just from an end user or customer standpoint, but also from a safety standpoint, right? That, there's less accidents because these parts that your brakes didn't fail because you knew days in advance that this was potentially something that could happen, and you went to the mechanic. And maybe a separate sort of objective or holy grail, if you will, that I see in this market, the concept of multi-material printing. So being able to take materials that are printed on a variety of technologies and being able to do it all at once or in some sort of uniform process opens up a lot of doors, because as I look across the broad spectrum of different technologies used to 3D print, you can see that each has sort of its pros and cons. But being able to start looking at how powerful that portfolio of manufacturing processes could be if they were combined, I think is incredibly interesting and could have an amazing impact on the world we live in.
Yeah, the reason I ask is, smart devices are starting to proliferate, so it would be nice if the electronics would be integrated into the devices themselves. So that's why I figured that would be an up-and-coming thing for 3D printing.
Yeah, exactly. And again, coming back to kind of the wearables technology and having, one automated process to manufacture something that is built for you as the user, right? And that is, like Keith said, there is some limitations now with multi-material printing and trying to get out of assembly, which, you could probably print all of the components for any wearable one-off, but then you still have to have somebody that assembles it, right? And to be able to build out a multi-material platform would help to overcome a lot of these issues.
Well, very good. So what's the best way for folks to find out more about, the evolved material and the platform and more about Dow Industrial Solutions?
So if you'd like to Google Evolve 3D, that's one very simple way to be able to find us. Maybe aside from that, we're usually present at quite a bit as far as trade shows and things like that. Our website, dow.com/evolve3D is always there. But I would say just in general, we'd encourage that. We're always excited to be able to talk with end users that share the same passion that we do for exploring the potential and the possibilities that 3D printing enables. So we'd be very excited to continue learning and partnering and collaborating to hopefully innovate and expand the application space in this area.
All right, well, very good. Well, guys, I appreciate you coming. Thank you so much for being here.
Thanks, Richard.
Thank you for having us.
You're listening to the Future Tech Podcast with Richard Jacobs. Future technologies such as artificial intelligence, stem cells, 3D printing, gene editing, Bitcoin, blockchain, the microbiome, quantum computing, virtual reality, and exploring space are much closer than you might think. In fact, many early versions of these technologies are in play right now, and the companies that are using these technologies are the focus of this podcast. My goal for you, the listener, is to learn from these podcasts. You may very well learn something that may change the course of your life for the better, steer you towards a new career, or give you insight into addressing a thorny medical problem. Remember, this podcast and its content is informational in nature only. No medical, tax, legal, financial, or psychological advice is being given. If you enjoyed the podcast, please listen, subscribe, like, and tell your friends about it. Thank you.